Okay, for the modulus and argument of 2, let's look at 2a first, right? So we want to find the modulus and argument. The modulus of a, very quickly, you know, if you take the modulus of negative 2i, right, this just equals to 2. Right, because if we were to think about, remember we are finding the magnitude of the complex number. If we were to look at the complex plane, negative 2i, where will it be? This will be the real, this will be imaginary, right? Negative 2i is actually somewhere here, right? So it's a negative 2i. You can see that the distance from the origin, right, is actually just 2 units. So the magnitude is just 2, right? They're just looking at the length or the magnitude of this complex number. Okay, argument, what's the argument? So you can see argument is always taken, right, from the positive real axis, right? So over here, this is a positive real axis, right? Where's the argument? You can see that the argument is just negative pi over 2. Okay, right, so the argument of negative 2i is just equals to negative pi over 2. Alright, so with that we have found the modulus and the argument. And next we want to express the complex number in polar form. Alright, in polar form. Okay, so quickly, recall that the polar form of a complex number, it must be written in the form of z equals to r cosine theta plus I sine theta, right, bracket. Okay, where r has to be positive part r, we're talking about the magnitude, right? So here it's, a lot of students may think that negative 2 is the magnitude, but it's not. Remember, r has to be positive. Okay, so on top of that, theta will be the argument. So since we have found the modulus and the argument, we can say that negative 2i written in the polar form, alright, it's just equals to r, which is 2, cosine of negative pi over 2, which is theta, the argument, plus I sine, right, negative pi over 2. So you take note that it has to be important things to represent in polar form. This has to be a plus. So you cannot say this is minus pi over 2, okay? You cannot say that. This also has to be positive, right? Only then can we say this is the polar form. Okay, very quickly again, can you write the exponential form, right? Remember that exponential form is just z equals to r e to the power of I theta. So quickly, for our 2a, z in the exponential form, z equals to 2 e to the power of negative I pi over 2, right? So this is the exponential form. And this answer here will be in the polar form. Okay, and we are done with 2a.